A physical cable known as an attachment unit interface, an AUI, connected a transceiver to an NIC in a computer. The transceiver was usually remote from a computer. For example, in an office building, transceivers might attach to an Ethernet in a hallway ceiling. This figure illustrates how the original thicknet wiring used an AUI cable to connect a computer to a transceiver. Hardware used with thicknet was divided into two major parts. A NIC handled the digital aspects of communication. A separate electronic device called a transceiver connected to the Ethernet cable. It handles carrier detection, conversion of bits into appropriate voltages for transmission, and conversion of incoming signals into bits. A second generation of Ethernet used a thinner coaxial cable that was more flexible than thicknet. It was formally named 10^2, meaning that the data rate was 10 megabits per second and the maximum cable length was 200 meters. It is informally known as thin wire Ethernet or ThinNet. ThinNet integrates a transceiver directly on the NIC and runs coaxial cable from one computer to another. The figure illustrates ThinNet wiring. ThinNet had advantages and disadvantages. The primary advantages were the lower overall cost and ease of installation. No external transceivers were needed and ThinNet cable could be installed in a convenient path. It was much easier to handle than the thicker cable that was used in ThickNet. The chief disadvantage was that the entire network was vulnerable if a user unplugged a segment of the network to relocate wires or to move a computer. The entire network would stop working. A hub emulates a physical cable, making the entire system operate like a conventional Ethernet. A system that uses a hub in carrier sense multiple access collision detection, CSMA, CD, to detect when it is safe to transmit a frame. The hub transmits a copy of each frame to all nodes on the segment. Each node uses the address to determine whether to process or ignore the frame. Twisted pair Ethernet retains the same frame format as previous versions. In fact, software on a computer cannot distinguish between thick Ethernet, thin Ethernet, and twisted pair Ethernet, and the NIC handles the details and hides any differences. Twisted pair Ethernet appears to follow a star topology. In fact, the term hub arose to clarify the concept of a central interconnection point. However, because a hub emulates a physical cable, the system appears to perform as if computers attached to a cable. In fact, professionals joke that a hub really looked like a bus in a box. To understand Ethernet topology, we need to distinguish between logical and physical topologies. Logically, twisted pair Ethernet employs a bus topology, but physically, twisted pair Ethernet forms a star-shaped topology. The arrangement of wiring used for LANs make little difference in a machine room or laboratory. The type of wiring makes a major difference in terms of the type, number of wires needed, the distance spanned, and the cost. The three versions of Ethernet wiring illustrate the three principal forms that LANs can use. This figure depicts wiring on a floor of an office building. Note that twisted pair Ethernet requires many individual cables to go between offices and a central point, like a wiring closet. Thus, twisted pair Ethernet requires careful labeling of cables. Note that twisted pair Ethernet requires many individual cables to go between offices and a central point, like a wiring closet. Thus, twisted pair Ethernet requires very, very, very careful labeling of the cables. Significant improvements have been made in the quality and shielding available in twisted pair cables, and the data rate used on twisted pair Ethernet has increased. The table summarizes various types of twisted pair Ethernet and the cable used with each. Note that the speeds of megabits per second do not include the data rate in the designation. Higher speed Ethernet technologies use an electronic device known as a switch rather than a hub. Ethernet technologies remain backward compatible. The technology standards for the higher speed versions specify that interfaces automatically sense the speed at which a connection can operate and slow down to accommodate older devices. For example, if one plugs an Ethernet cable between an old device that uses 1000 base T, that's 1000 megabits per second using twisted pair, and a new device that uses 10 G base T, 10 gigabytes per second using twisted pair, the new device will auto-sense and slow down the rate to the 1000 megabits per second rate. Couple of different types of Ethernet cables. UTP is unshielded twisted pair. STP is shielded twisted pair. SCTP stands for screened twisted pair. It's most widely used in Europe. FTP stands for foil screened twisted pair. SUTP stands for braided screen with unscreened twisted pair. Twisted pair Ethernet uses RJ45 connectors, which are very large. They're larger versions of the RJ11 connectors used to connect telephones. What is straight and crossed Ethernet cable? A straight cable is used between a computer and a switch and a router. Each pin of the RJ45 connector attached on one end of the cable directly corresponds to the same pin on the RJ45 connector at the other end of the cable. Pin 1 is attached to pin 1, and so forth. To help technicians make correct connections, individual wires in Ethernet cable are coated with colored plastic. This might seem familiar from when you were making your patch cable a few weeks back in our patch cable lab. The table lists the color codes used with a straight cable. White, green, green, white, orange, blue, white, blue, orange, white, brown, brown. Twisted pairs carry complementary signals. A crossed cable is used to connect two switches or two like devices, such as connecting two PCs together. It connects a pin on one end to a different pin on the other end. The internal wiring of crossover cables reverses the transmission and receives signals. It is widely used to connect two devices of the same type, for example, two computers or two switches to each other. A feature of Ethernet called MDIX provides the necessary auto-detection support to prevent these signal conflicts. It allows Ethernet interface to automatically determine which signaling convention the device on the other end of the cable will be using, and negotiates the transmit and receive wires accordingly. Only one end of a connection needs to support auto-detection for this feature to work.